Now that we have some information about the slopes of parallel and perpendicular lines, let's look at how to use that information to write the equation of a line. Here we have a line L. It says that a line L is parallel to the line with the equation y equals 17 and 2/10 x minus 340 and 9/10. But L has y-intercept at 0, 128 and 2/10. What is an equation for line L? Well, we are told that line L is parallel to the line given to us. That's helpful because since they are parallel, we know that the slope in the given equation is also the slope for line L. They're going to have the same slope. So we know that our slope for line L is going to be 17 and 2/10. They also gave us the y-intercept as a point, which means our B is going to be 128 and 2/10. Well, we have our slope and we have our intercept. That, to me, looks like we can use the slope intercept form, y equals mx plus b. If we go ahead and plug in our m and we plug in our b, we now officially have an equation for line L. Now, sometimes the information that we are given is not quite that simple to just plug in. Sometimes we do have to do a little bit more work. So let's look at this problem. It says line A and line B are perpendicular. Line A's equation is 2x plus 3y equals 2. And line B passes through point 4, negative 3. This time we're writing an equation for the line B. Now we have an equation for line A, which means we can actually find line A's y-intercept and its slope. But we don't have either of that information for line B. However, if we know that they're perpendicular, if we find the slope for line A, we know the slope for line B. And if we know the slope for line B and we have a point, we could use point-slope form to solve that. So let's look and see if we can find the slope for line A. So line A, we have 2x plus 3y equals 12. And if we write this into slope-intercept form by isolating our y variable, we will have our slope. Remember, we're subtracting the x from both sides to get the y by itself because we want the x and the y on separate sides. And then we're going to divide everything individually by 3 so that we have a fraction for our slope. And our slope is going to be negative 2/3 for line L. Now line B is going to be an opposite reciprocal because they are perpendicular. So my slope for line A times my slope for line B should give me negative 1. If line A is already negative, then line B is going to be positive. And so I just need to flip line A. And it's a fraction already, so all I need to do is flip, which tells me that my slope for line B is just going to be 3/2. So now the last thing I need, I have a point, and now I have a slope. So I'm going to use point slope form. And this formula is from our previous section. I don't remember the section number off the top of my head. Let's see. Section number 1, 2, 3, 4. Oh, that's wrong section. That's wrong chapter. 1, 2, 3, 4, 5, 6. Section 4, chapter 4, section 6. This is from that section if you need to go back and review how to use this equation. But we have a point. Our point is going to be our x1 and our y1. And we're just going to plug it in. So y equals 3/2 x minus 4. And then plus our y. In this case, it's plus a minus, or plus a negative number. So it's just going to become a subtraction. Now, this is technically an equation, so I could leave it like that. I do want to go a little bit further because in some of your problems, it will ask you to write your answer in multiple ways or in a specific way. So if it asks you to write your answer in y-intercept form, then you would go a step further and distribute that 3/2. 3/2 times 4 is 12, and 12 divided by 2 is 6. And this is another equivalent equation for line B. And another way, another form that you might be asked to write your equation would be in standard form. And with standard form, we want x and y on the same side, which means I would want to subtract x from both sides, which would give me negative 3/2 x plus y equals negative 9. And once again, if you wanted to leave this as a whole number, you could multiply everything by 2. And if you want to get rid of that negative, you could multiply everything by negative 2, which would give you 3x minus 2y equals 18. And these 4 that I have boxed in are all equivalent equations for the same line. If you were to plug them into Desmos graphing calculator at desmos.com, you would see that these would all graph the same line. Last one I want to do before I end this video is, in this case, you are given 2 lines, information for 2 lines, and asked just to determine if the lines are parallel, perpendicular, or neither. This is a very common type question that's given in math books for parallel, perpendicular, or neither questions. So once again, to determine if they're parallel or perpendicular, we compare their slope. So we need to find the slopes. We need to find the slope of line L as well as the slope of line N using our slope formula. And I'm just going to rewrite the, actually want to move this here because the formulas are going to go horizontally. And I'm going to go ahead and write the formula twice. So we'll say that this first one for both of them is our 0.1, and the second one for both of them will be our 0.2. So 8 minus 4 and negative 27 minus negative 9. Minus a negative is the same as adding it. So 8 minus 4 is 4, and negative 27 minus 9 is negative 18. 2 goes into both of these evenly, which will leave me with negative 2/9. For line L, or line N, I have negative 5 minus negative 11, negative 18 minus 9, minus a negative once again is positive. So negative 5 plus 11 is 6. Negative 18 minus 9 is negative 27. 3 goes into both of these evenly. And 6 divided by 3 is 2. 27 divided by 3 is 9. And these are the same. And they both have negatives. I keep pushing around buttons. They both have negatives. These are the same. Therefore, these are both parallel. And that is parallel and perpendicular lines.